So we're going to look at number 49. And I'm going to read what we got here. What are the directions? Use the graphs of f and g to evaluate the function. So I was supposed to use those graphs to do it. Okay? And then they asked me in 49 in part A to do f of g of 2. So what that means is find g of 2 and then take that answer and find f of that. Okay, looking at the graphs on the bottom of page 235, what is g of 2? Do you see it? What's g of 2? Do you know how to do it? No equation, just what's g of 2? That means when you plug 2 into g, what output comes out? Right. Now, go on to the second part. Now you've got to find f of that. So I got to find f of 2. So now move over to the f graph. And what's f of 2? So there it is. F of g of 2 is final result 0. Let's do part B. Part B says, what's g of f of 2? Oh, this is different. I got to start with f this time. What's f of 2? 0. And now, what's g of 0? Final result. Correct. Another 2.6 question. Emily? What's happening in this part? Find f of g, and then in part B, find g of f. And find the domain of each, and find the domain of each composite function. Okay, well, first of all, let's do f of g of x. So that means I have to start with the x plus 3, and now I have to apply function f to it, which says take its reciprocal. All right, so 1 over x plus 3. Whereas g of f of x, this time I have to start with 1 over x, and what does rule g say? Take whatever I give you and add 3. So this time it's just 1 over x, strategic pause, plus 3. Please note those two are not the same. Now, any questions about, I don't know if I said enough to help you. Okay, now, I haven't done up here is, what's the domain? Well, what was the domain of the original function of f? The only thing x can't be is 0. What's the domain of this? No restrictions, right? All real numbers. All right, now, how about f of g of x? What's the domain of this? X can't be negative 3. And what's the domain of this? G of f of x? X can't be 0. That pretty much wraps up. That's what they wanted me to do. Allie? Okay. 29. So you're supposed to use a graphing utility to graph f, g, and f plus g in the same viewing window. Okay, so let's start with that. So I'll pull up that graph program. Okay, so the first one is 3x. And we'll let that be red. Okay? Second function we want to look at is g of x, and we want that to be negative x cubed over 10. And we're going to change this to, I don't know, should we do blue on this one? So this is negative x cubed divided by 10. Okay, and then I want to do the addition of those two, which is the f plus g, and let's do that in black. So I got to change the color here to... Okay, so this one is 3x minus x cubed over 10. I know I probably should zoom out a little bit on this. Okay, so there's the graphical result they were hoping you would. Now what else does it say? Which function contributes the most to the magnitude of the sum when you're between 0 and 2? So between 0 and 2, remember, the two contributing ones are red and blue. Black is just kind of the answer. So between 0 and 2, right in here, which contributes the most to the black answer? Obviously the red. Because look at how close it is to the red and how far it is from the blue. I can't remember. What else did they say? Which function contributes the most when the sum is greater than 6? So when we're past 6, past here, now the blue contributes the most. You notice how the black is not anywhere near the red, and we're getting much closer to the blue. So I think that's kind of what they wanted you to see. I promised I would. Is anybody still waiting yet for the link to how to download that program? You are. Okay, I found the link and I sent it. Were you able to get it? You haven't tried it yet? Okay. I got to remember to send that to Heidi. So send graph link to Heidi. All right. Any other questions? Megan?
Go back to 49. I missed that last word.
Yeah, I don't remember what we did on that. I lost it already. Let's see, 49. Oh yeah, this is the one we were doing visually. Okay, so you got your book opened up to 235. Okay, on part A, they say find f of g of 2. Now, first of all, that means what? F is on the outside and g is on the inside, right? It's like f of g of 2. So I got to do the g of 2 first. So back on, looking at the graph, look at the g curve. What is g of 2? That is, when you move over to 2 and move up to the graph, where do you end up? What height do you end up at? So that's that. Now, what's f of 2? Now move over to the f curve. So the final result for part A, what is f of g of 2? Ended up at 0. No, you're not multiplying. You're just taking f of the answer to the g part. It's not the same as multiplying. Okay.
I'm gonna have to see that.
It's a chain reaction. Here's the deal. I'll try to explain it best here. So because we had what, f of g of 2, we knew we had to do the g first. So we came over here and we said g of 2. Okay, that's at a height of 2. Now you take that answer, 2, and now find f of that. And what's f of 2? 0. So it's not a multiplication, it's just a chain reaction thing.
So
Got it?
going backwards,
Yes.
f of 0 and what's g of 0, right?
Yes, and that is?
4.
Yeah. So it's not a multiplication process, it's just a, what, doing it in the right order? It's a sequence thing, more than anything. And again, are you shocked by the fact that the two answers don't come out the same? No. I would say 99.99999999999999999% of the time they won't. Okay, there are special cases where it will come out the same, and that's when f and g are exactly inverses of each other. And here they obviously are not. And today, guess what? We're going to concentrate on how to find an inverse. So today, all the problems we do inverses on, you'll be able to reverse the process. Maybe one more? That quiz in there threw us a little time wrench today. So let's do the inverse thing. 2.7. This is what? The last official lesson of Chapter 2? So I'll just remind you of the schedule here. If everything works the way I predicted, today we should be able to wrap up 2.7. That's the last lesson. Then Friday would be what I call Review 1. And you could ask questions about your 2.7 assignment. Monday, I call Review 2. Final review, maybe you might have tried the practice test in the book, types of things. And then Tuesday is the test on Chapter 2, and I believe that's what I told you, right? Okay. So we're still on schedule. All right, what are the objectives here? How do you find the inverse of a function? And how do you verify that they really are inverses of each other? Okay, we're going to go through that. How can you use graphs of functions to find out whether functions have inverses of each other? And then here's a new one, 2.7, the third objective. Use the horizontal line test to determine if functions are one-to-one. Yeah, that's because up until now we've only been using a vertical line test because we've only been checking for is something a function. This is the first time we've tried to figure out if they're one-to-one. What's that? We're going to show you that today. Okay, so let me just show you one quick example. I don't usually talk. I've got an independent website that I've been running. I don't know how many of you've made use of it at all. And I haven't been pointing to it too often, very seldom. But I thought today I'd pull an example off that. We have a function here, 2x plus 4. Good old mx plus b. How could I find its inverse? Well, here's a step-by-step. So if nothing else, I hope this is a reminder to you, if you haven't been using that. I think it's a worthwhile resource. Okay, here's the original equation. Okay, step 1. Put a y in place of the f. You'll see y in the next step. Y works better for what we're going to do next. So instead of calling it f of x equals 2x plus 4, just call it y equals 2x plus 4. Now here's the inverse part. This is going to seem really strange. Swap the x and the y. Literally trade them. So where I had y equals 2x plus 4, I now have x equals 2y plus 4. I just took the x and the y in. Okay, now solve for y. So this is simple algebra. From here on in, just solve for y. When you get all done, you've got the inverse. It might be a little tiny, so I'll tell you what, I'll do it a second time up here. So what is it, 2x plus 4? So the first thing we did was we just called this f of x y. Now, literally, swap the x and the y. Now, just solve for the new y. So we want to get the new y alone, so we're going to subtract 4 from both sides. And we're going to divide both sides by 2. We could leave it like this, or couldn't we also write it like this? This looks a little better because now you can see the mx plus b form again. And when you get done, you don't have to do this, but you replace the y again, and this time you say f with a little minus 1 exponent. That notation stands for f inverse of x. Thanks. You know, there's a notation that suffers a little bit. They're always trying to find, you know, these mathematicians are always trying to find these really cool shortcuts, okay? And they'll go, oh, I've got a great idea. Let's do this because, oh yeah, it's nice and short, you know, forever, I don't know, some of the laziest people on the planet. But anyway, this one suffers a little bit. Here's why. Because when you take f to the minus 1 power, what does that mean when you take something to the minus 1 power? You know, if I gave you the number 5, what is 5 to the negative 1 power? What'd you say? Okay, now don't give me a decimal, please. 1/5. It's just reciprocal, right? You're right. That's what the calculator is correct. But it's 1/5. So what does negative 1 power do? It takes a reciprocal. Now, I will admit that reciprocal is one form of inverse, right? What's another name for reciprocal? This is a tough one, but sometimes it's called the multiplicative inverse. But there's another kind of inverse. There's an additive inverse. What's the additive inverse of 5? Negative 5. And so, my only problem is they're trying to say inverse in a general way here, and they've used only the multiplicative inverse. And it suffers a little bit. They're not always reciprocals. Inverses are, I mean, it depends on what the problem had in it. So, just a little comment. I'm a little disappointed in this notation, but nevertheless, that's what it means. F inverse of x is what that is trying to tell you. Okay, here's another one, and I'll do this bigger too. But on this one, I took something a little more complicated. X, this function is function g, x squared minus 3x plus 9/4. Your mission, should you decide to accept it, is to find the inverse of that function. No. Okay, so anyway, now, first thing you do is you change f of x, or g of x to y, and then you do this swap thing that I told you about. Now, I did make one other, I made one other change here before I swapped. This is a ding-ding-dinger. Thanks. This is a perfect square trinomial. So I wrote it as a perfect square. I mean, how do I know? Remember, the first term has to be a perfect square, x squared. This has to be a perfect square, 9/4. It's 3/2 times 3/2. And if I take what? If I take the square root of the first term times the square root of the second term, that's x squared times 3/2. That's 3/2 x. And double it, I get 3x. And that's the middle term. Therefore, this is a perfect square trinomial. So I wrote it as x minus 3/2 squared. Now, I did my swap operation. Where there was a y, now there is an x. Where there was an x, now there is a y. Now, have fun solving for y, because it really is fun, especially the way I wrote it. How do you get y alone? Well, don't I have to get rid of this square first? So I could take the square root of both sides, both of them. So this side, goodbye square, left side, square root x. then just get rid of the minus 3/2 by adding 3/2. Okay. And we wind up with G inverse of x equals plus or minus the square root of x plus 3/2. I guess I was going to do that bigger. I'll do a different one bigger. Well, let me show you this before I do that. Anything I can help you with? I know it's not easy to see that. Yeah, what that says down there is therefore, just a triple dot. Therefore, in other words, I'm done. G inverse of x, that's G with that little minus 1 exponent of x, equals plus minus square root x. And then outside the square root sign, plus 3/2. Now, I'll come back. We're going to do more of these, but what I want to show you something special. Do you remember when we did the 2x plus 4 guy a few minutes ago? Okay, the 2x plus 4 guy, when you graph them, is this, I know you can't see color, the colors are pretty dull. This red line right here is 2x plus 4. And my inverse was 1/2 x minus 2. And that is this yellow line. Now, I threw another line on top of here. And that's what? The lazy man's function? Otherwise better known as the identity function, y equals x. Do you notice something about that, especially if you take your head and tilt it so that it's oriented along the green line? The red and the yellow line are exact, perfect symmetry copies of each other. Do you see that? If I folded this over, it would land right on top of that. That will always happen with inverses. Inverses are always the symmetric image of the guy they were the inverse of. When it comes with the comparison always being the identity function, the green line. Let me show it to you with that second one. So this is a remarkable principle, okay? And it actually shows up graphically. Here's the one we just did a few minutes ago. X squared minus 3x plus 9/4. Okay, that happens to be this red parabola right here. That was the original function. Then I found the inverse, and I got this plus or minus thing. And that's these two curves, the yellow and the black. Here's the inverse. Then I threw the identity function on there, and look. This is a perfect mirror image of that. That will happen every single time. An inverse is always the mirror image of the original function with respect to the identity function. And in fact, they may have you use that principle in a couple of your assignment problems just to verify. Did I really find the inverse? If I did, when I graph them on the same grid, and I turn my head 45 degrees to the right like that, I should be able to see if they're mirror images of each other. Okay. So, yeah, I guess let me show you this principle too. Another cool thing about an inverse. All an inverse does is completely reverse what a function did. I mean, it's literally it's the opposite. So, for example, I'm not even going to tell you what function f is, but I'm going to tell you this. F of 2 is 3. And you know what happens when you take f inverse of 3? You're going to come right back to where you started. So do you see how these two ordered pairs are just literally swapped? Just like we did, right? Didn't we take the x and the y and do this? Sure enough, look what happens. Or over here. I don't even know what function g is, but if g of 7 is 100, I can tell you this, g inverse of 100 is definitely 7. So an inverse just literally takes the ordered pair and like undoes it, flips it back. Okay, so it's another good picture of an inverse. I guess it's time to dig in and do some problems. So let's look at number 10. I think that's number 10 from this assignment. Let's make sure. Yeah, x minus 1 over 5 is the function. Your mission is to find the inverse. So anyway, what you do is, first of all, put a y in place of f of x. Then do the swap. Right? From here to here is where I did the swap, right? Otherwise, this thing screams out to you, I just did some illegal algebra. You can't swap x and y when you're solving, but when you're trying to find the inverse, you have to. So, okay, so that's why I did this. Now, solve for the new y. So I had to get rid of the divided by 5. So I multiplied both sides by 5, and I got this. And then I wanted to get y alone, so I added 1 to both sides. Here we go, 5x plus 1. Hey, let's see if that inverse thing really works. Okay? So go back to the original. What is f of 6? F of 6. Right. So now, what is f inverse of 1? Here's f inverse. What's f inverse of 1? I should go back to 6 if it's right. You see how it works? And what should happen if I plot these two on a graph? Let's prove that one more time. So let me pull out the graph. I got it here. And I'm going to, first of all, hide these guys. I love that feature. And now let's put these two guys in. What were they? You guys remind me, what were they? X minus 1 over 5, thank you. So there's that one. And then the second one was 5x plus 1. And let's make that, what, blue? Oh, some ugly colors there. So this one we're going to make 5x plus 1. And now, just to round it out, should we put the identity function on here? Yes, let's do that, please. Okay. I know, I'm talking to myself now. It's not a good sign. Okay, now tilt that thing 45 degrees, and you can see, oh yeah, we've got this perfect mirror imaging thing going on. Yeah, that really does work. Okay. What's number 16? 16 is in a different section. It says, oh yeah, and I haven't told you how to do this yet, so that would probably be nice to do. Wouldn't that be cool if I showed you how to do something before I had you do it? Yeah. So here's the deal. It says we already found the inverse. Prove to me 2 ways that these things really are inverses. Well, one way is to do what we just did and put them on a graph and show me that they're mirror images. I just did that on the other one, so I'm not going to do it on this one. The other way is this. Now here, I haven't told you this before. If 2 functions are actually inverses of each other, then when you compose them in either direction, the answer will come out to x. So, let's compose them. So here they are. Number 16, they give you these two. They say this is F and this is G. I believe those are correct right out of the book, right? They gave them to you. How can we prove algebraically that they're inverses? Way 1, find f of g of x. Okay? Well, g of x is this guy, and what am I supposed to do with it? I'm supposed to multiply it by 4 and subtract it from 3. So take this guy, multiply it by 4, and subtract all of that from 3. When you simplify that, what happens? Well, doesn't this 4 cancel here? Yes. And then you have this, and then when you apply that minus sign correctly, doesn't that become minus 3 plus x? And you get x. Voila. That's exactly what I was supposed to get. If you compose two functions and you get just a bare naked x, that tells you that, sorry I used bare naked. What that tells you that those two things are inverses of each other. Now, let's do it the opposite way. Let's do g of f of x. Okay, this should also work. So this time I have to start with this guy, and I have to do this rule, which says take what I give you, subtract it from 3, and divide it by 4. Take what I give you, 3 minus 4x, subtract it from 3, and divide it by 4. Okay, if you carry out the minus sign on the top, doesn't this become 3 minus 3 plus 4x? And 3 minus 3 is gone. And sure enough, the 4's cancel, and again, voila, I get x. We have proven algebraically that this is the inverse of this, and vice versa, that this is the inverse of that. Once you found inverses, they're inverses of each other. The only other thing we could do is, can we show this on a graph? I guess I'll do it one more time. So again, pull up a graphing utility. I don't know how many functions I can put in here. Let's see. Okay, so somebody again, what was f? All over. Oh, it's just 3 minus 4x. Thank you. We'll have that be blue. Okay, next. Three minus x over 4. Okay, now I'll throw on the identity function. Well, I already got it. Save myself a little bit of time. There it is. And once again, do the old tilt the head thing. Hey, I got it. By the way, if you don't want to tilt the head, you can also take your paper, this is real tricky, and tilt it back to the left. I decided I won't do that with the projector because it means I'd have to break the bracket. But, yeah, so anyway. Yeah, I've lost it. That's okay. Yep. A syntax error? It means it doesn't like, you gave it a command, it says nobody taught it how to do that.
Like every time I go.
I'll have to look at it. It's hard to say what's causing that. Well, I'm just trying to look at the other rules, the other sections.
Yeah.
I guess we're ready for the assignment. Okay, assignment 2-7. Somebody I gave this to already. Wasn't going to be here. But I didn't write it down. You're the guy. Good, thank you. 1 to 61 every other odd. Yeah, 1 to 61 every other odd. And I think we've covered everything for that lesson. See you on Friday.